Formation of stars. For the formation of stars there are main 7 stages: molecular cloud or giant gas cloud, protostar, T-Tauri phase, main sequence, red giant, fusion of heavier elements, supernova and planetary nebulae. Everything begins with the molecular cloud or stellar nurseries. Molecular clouds are a mix of molecules, atoms and dust. The molecules present in molecular cloud are typically hydrogen and some complex molecules like methanol and water. What happens next is a long process. This ball of gas and dust do not stay in the same place as time passes. There occurs a turbulent motion. This turbulent motion of the dust and gas distributes the atoms and molecules unevenly so that some regions of the molecular cloud will have more matter than other regions. When the gas and dust pile up to a very high level in a certain region, that region starts to collapse due to the pull from its own gravity. This results in the squeezing of matter and the density of the matter will increase. After the collapse, the molecular cloud starts to heat up. Now the contraction occurs, and when the collapsing region reached the size of nearly 10,000 astronomical units, it is called prestellar core. Over the 50,000 years the prestellar core contracts until it is around 1,000 astronomical units. Now after this contraction the system will have formed the disk around the central core and the excess material creates the poles of the star. Now this entire system starts to spin around and these poles, which are called jets, arise to keep the system balanced. The system is now a protostar, which means it is at its very first stage of becoming a real star. We know that the protostar has a disk around it which is mainly made up of gas. So when the disk slowly approaches towards the surface of protostar, the gravity of the protostar attracts the stuff of disk, resulting the star starts to grow bigger in size. This process of growing is called accretion and the star is said to be accrete the matter from disk. Till this stage the star is invisible because no nuclear reaction has been taken place. It's all black. Now after accumulating the matter from the disk, the star has grown enough in size and density and is ready to initiate a nuclear reaction, which causes the star to shine like the sun. This star is now called the T-Tauri star. And this is the first time star can be observed visually. The star eventually stops excreting matter from the disk, but the remaining material around the star is still in disk-like shape. This material will start to clump together and start rotating around the star. These clumps made from leftover material from the star's creation will form the planets. This means that the planets in our solar system are made from the leftover material from the sun's birth. This is also the reason why all the planets are found in the same plane. After the solar system is formed, the star is now in a main sequence phase which is stable and glows brightly. This is the stage that our sun is at right now and will be shining for billions of years. As the main sequence star glows, the hydrogen in its core is converted into helium by nuclear fusion. When the hydrogen supply in the core began to run out and star is no longer generating heat by nuclear fusion, the core becomes unstable and contracts. The star has now reached the red giant phase. It is red because it is cooler than it was in the main sequence. All the stars evolve in the same way up till their red gained. Once the massive star reached the red giant phase, their core temperature increases as carbon atoms are formed from the fusion of helium atoms. Gravity continuously pulls carbon atoms together as the temperature increases and the addition fusion process proceeds, forming oxygen, nitrogen and eventually iron. When core contains essentially iron, fusion ceases because iron is the most compact and stable of all the elements. Since energy is no longer being radiated from the core, in less than a second the star begins the final phase of gravitational collapse. The core temperature rises to over 100 billion degrees as the iron atoms are crushed together. Then a shock wave occurs, which we see a supernova explosion. Depending on the size of the star before it explodes as a supernova, the core of the star either shrinks back into a tiny neutron star, or becomes a black hole. When a low-mass star dies, planetary nebulae is born. In low-mass stars, the outer envelope of the star is ejected out. while the core of the star becomes a white dwarf.